There's this amazing package from Miles Salmon called riem, R for Iowa Environment Masonet, which is a service hosted by Iowa State University that collects weather data from all over the world. This package makes it super easy to extract the weather data from the service and import that into R. So let's take a look. First, let's install this riem package. You can type the package name and click Install button, and you can confirm it is installed already. Let's create a new project. Inside the project, we can select Import by writing our script so that we can call riem package functions directly. First, we want to call a function called riem_networks from the package, which will return all the networks in the world, typically by US states or countries. Then find the network or area that we are interested in. In this case, we find CA_SOS is a network code for California. So we can note this down and call the next function, riem_stations, which will return all the stations that collect the weather information by passing the network code. Since it has longitude latitude information for 146 stations, we can visualize this quickly with map and pick the station that we are most interested in. Let's pick this SFO station, which is San Francisco International Airport, and now we can create a new data frame by writing our script again. We can use riem measure function, setting SFO as station ID, and set start date. Downloading that data takes time depending on the network speed, but it took about a minute for my environment. Once we get the data in the preview, then we can simply import this into our environment. We can quickly see the data in summary view, and we have this column called temp_f, which is temperature in Fahrenheit. We can quickly visualize this data by assigning valid column to x-axis and select week is the aggregation level. Now we notice there are huge volume of data over the last 6 months or so compared to other time period. We can go check table view for more detail by resorting that data. It turned out that the temperature data is collected for every hour, but some data was collected for every 5 minutes. Since we are interested in only the temperature data now, we can safely remove the rows whose temperature data is NA. Now go back to the same chart. Now it looks much better. Now we can assign temp_f column to y-axis and set the function to average and change the chart type to line. Now these values are average of each week based on all the hours of the days, but how about we want to know the average based on a specific time, say 2 p.m. in the afternoon? Well, we can use our function and filter the date to 2 p.m. quickly. But one thing we need to be careful, when we set 2 p.m., which time zone are we really talking about? If we assign hour to x-axis, temp_f to y-axis, and set to average, this line chart looks weird. Even though I'm not an expert on weather, I can tell 8 p.m. should not be the hottest hour of the day. Well, it turned out that the valid date column in this data was registered as UTC time zone. So we need to convert to our local time zone. We can use with TZ function. The default is going to use my system's default local time zone, which is US Pacific time, and that is perfect for SFO. And we can move this time zone calculation before extracting our information from the valid column. Now it looks much better. Go back to the original chart. We can see the temperature range is now between 50 and 80 degrees in Fahrenheit. Now how about comparing against other cities like New York City? Well, basically we can do the same thing we did for San Francisco. Go back to the station data frame and open the data import dialog and get station data and visualize the stations with map. Pick a station, in this case that is LGA for LaGuardia Airport, and create a new data frame. Use riem_measures function to get the data for New York City weather. We can do a quick cleanup by removing the rows whose temp F column values are NA, just like we did for San Francisco data. And we can also convert the time to the local time zone. In this case, that is US New York time zone for this New York City data. Then we can extract the hour information on top of that converted data. Now go back to SFO data frame and use bind rows command to merge SFO and LGA data frames together. Once they are merged, go back to chart view and assign station to color. You can see the peak of summer in New York City is much earlier than the one in San Francisco. Lastly, we can quickly filter to show the average temperature based on 6 p.m. 70 to 80 degrees after 6 p.m. sounds like a good time for drinking beers outside after work. I miss the New York summer.